Today, we'll be solving LeetCode 235, lowest common ancestor of a binary search tree. This problem gives us a binary search tree, and two nodes inside it. Our goal is to find the lowest common ancestor of those two nodes. The lowest common ancestor is the deepest node in the tree that has both nodes as descendants. Think of it as the first common point in the tree where the paths from the root to both nodes meet. Because this is a binary search tree, we can use its property to solve this efficiently. In a binary search tree, for any given node, every value in the left subtree is smaller than the node's value, and every value in the right subtree is larger than the node's value. Here's the idea: we start from the root node. If both target nodes have values smaller than the current node's value, that means both are in the left subtree, so we move left. If both have values larger than the current node's value, that means both are in the right subtree, so we move right. If one is smaller and one is larger, or one equals the current node's value, then the current node is where the paths meet. It is the lowest common ancestor. Let's go step by step through the code. We start with a function named lowest common ancestor, which takes in the root of the binary search tree, and two nodes p and q. Then we write while root. This means while root is not none, keep looping. We will move down the tree one step at a time until we find the answer. Inside the loop, we first check if p.val less than root.val and q.val less than root.val. This means if both p's value and q's value are smaller than the current root's value, then both are on the left side of the tree. So we set root equals root.left to move to the left child. Next, we check L if p.val greater than root.val and q.val greater than root.val. This means if both p's value and q's value are larger than the current root's value, then both are on the right side of the tree. So we set root equals root.right to move to the right child. If neither of those conditions is true, that means we have found the split point. One node is on one side, and the other node is on the other side, or one of them is equal to the current root. In that case, we return the current root as the lowest common ancestor. The time complexity of this solution is O of h, where h is the height of the tree, because we only move down a single path. The space complexity is O of 1 because we are not using any extra space apart from a few variables. And that's how you solve LeetCode 235, lowest common ancestor of a binary search tree. Thank you for watching, and let's keep learning.